There we go. So I'm going to be talking about basis sets and output file types. But before I get into basis sets, I'm going to talk a little bit about atomic orbitals, because the basis sets are just approximations of these atomic orbitals. There's a lot of different ways you can do that. The one I learned about is with the Fock operator. What it does, it calculates your one-electron wave functions, and then it does exchange integrals and then Coulombic interaction integrals, and then it gets really messy really fast. So depending on what kind of job you want to do, you'll choose a different basis set based on how it calculates these atomic orbitals. And they do have these funny looking names like 3-21G, CCPV, DZ, and whatever. So what do these stand for? These names, they just, hello. There we go. Yes! Small victories, right? So they just tell us how these atomic orbitals are approximated. Like the 3-21G, it's a split valence theory, so it calculates the core electrons and the valence electrons just a little bit differently. The 3 it uses says 3 Gaussian functions for the core electrons. For the zeta function, that's coming out of Slater-type orbitals. It's a bunch of hand-wavy stuff. And then the 2 and the 1 are for the valence double zeta functions, valence functions. And then CCPV is a correlation consistent polarized valence D. That's your number of zeta sets. It's a little more quantum mechanically, a little more accurate. A lot more integrals. So there are 3 big output file types. Your output, your log, and your checkpoint. The checkpoint file is most useful if you're going to be doing more jobs. So like we did our geometry optimization. What you can do from there is you can submit it for your frequency and all the other types of jobs that Audrey talked about. I promise I didn't make it that way. And your log file is similar to a checkpoint file in that it can also be used to start more calculations, but it also codes in some more of the results of the previous calculation. And the output file, you don't usually use it to start a new calculation. That's where you go to sift through your eigenvalues, your thermochemical data, and other results that you don't put up graphically on screen. There you go.
Okay.
Questions?
But